Designing in 3D with SOLIDWORKS delivers unmatched productivity gains. Errors are reduced, parts fit together the first time, and physical prototypes can be eliminated. When designing products, knowing if it will work is critical. However, knowing how long it will last is just as important. Knowing a product's durability helps to ensure it meets customers' needs, as well as minimizing unexpected warranty issues. But how can we determine a product's durability? Let's look at the example of a bicycle crank. The strength of most materials reduces under repeated loading. This means that over a period of time, even a load well below the yield strength of the material may cause a part failure. This behavior is commonly called fatigue. Normally, it requires days, weeks, or even months of testing to ensure a part will last a desired time. What if we could test the life of a part in a matter of seconds to make sure we have the best design choice? SOLIDWORKS Simulation gives us that ability. By incorporating the material strength variation with load cycles, SOLIDWORKS Simulation can provide excellent insight into the life of a part. Here, we have 3 different crank designs, but we want to know which one will last the longest. They're all made out of 6061 T6 forged aluminum. Our goal is for the crank to last around 25,000 miles of riding, or roughly 7 million load cycles. Let's look at the first design. Setting up the test is incredibly easy. The first step is to assign our material properties that include the fatigue characteristics. These are used during the analysis to determine the number of cycles each area on the model can last. After setting the material properties, we then add fixtures. The fixtures represent how our part is going to be held for the test. In this case, we're going to lock rotation by holding the crank at the bolt connections to the gear sprocket, and also represent the bearing support that acts on the shaft. For our loading, we're going to assume the full weight of a rider is applied through the pedal to the crank. To represent this, we'll use a load of 300 pounds. It only takes a matter of seconds for SOLIDWORKS Simulation to calculate the results. We can see here the maximum stress in the model is 230 MPa. This is well below the 275 MPa material yield. This leads to the factor of safety of around 1.2. We now create a new study to test durability. We specify the static study we wish to check, and then enter the information on how we repeat the loading. With this information and the material properties, we can then determine how long the crank design will last. We can see for this first design that the minimum number of cycles is around 1.8 million, which is less than our 7 million goal. Let's now compare the first design to the other 2 designs. For the second design, we can see that the maximum stress is well below yield at 200 MPa. When we look at the durability, it's at 7.5 million cycles, just above our design goal. For the third design, the maximum stress is again below yield. But when we look at the durability, it's far below our design goal at only 730,000 cycles. So, the second design is clearly the one that will last the longest and also meets our design requirements. SOLIDWORKS Simulation helps you to design the best product and save on prototypes and testing.